Okay, greetings everyone. Welcome in to my channel. I am Professor L, and I am going to be sketching the graph of a step function. And I am going to start with the floor function tonight. So we'll see how it goes. I was intending on sketching this graph yesterday, and I failed. I don't know what happened, lost connectivity, and I had camera issues. So I really apologize about that if you were looking forward to seeing this graph sketched. But oh well, it happens. Things happen, and try again today. So the floor function is otherwise known as the greatest integer function. So that's what I'll title it. This marker is very squeaky. All right. So I'm just going to roll with it so that we have the greatest integer function, and f of x is the floor of x. And that is the notation for the floor function. And by definition, what this function does is it takes any value, any real number in the domain, and it produces, let's see, what it does is it produces a graph that looks like a staircase, because it returns, for any real number you plug in, it returns the nearest integer that is less than or greater than x. So n is greater than or equal, hang on, did I say that right? No, it's less than, sorry, less than or equal to x by definition. So there's a ceiling function and a floor function, and sometimes I get them mixed up. Anyway, so we are going to need a couple tables for this one, and we're probably going to need a fresh marker. So try and focus and see how this goes. All right, so I'm going to go ahead and start with one table of values, but I'm going to leave some room because I'm going to need probably several. So I'm going to say y equals f of x. And I'm going to go ahead and draw my Cartesian coordinate system. And happy Tuesday. I hope everyone is doing well. If you are watching and you do have a math problem you would like me to work out, you could always put it in the chat. And if I can do it today, I will. If I can't, I'll do it next time. All right, so we have this, Let's go ahead and get going and see what this function's doing. And really, I have to make a decision, because you read the graph from left to right like you would a book. And so I need to figure out values in my domain and where I want to see this function live. So it exists. The domain of this function, and I guess this would be the range, So the domain of this function is all real numbers. What that means is that I can pick any value on the x-axis that I want to, and it should return a value. It will return a value in the range. So I guess maybe we'll go from negative, we'll just say negative 2 to negative, well, yeah, we'll go -2 to +2 and see if we can't get a small chunk of this step function behavior pretty quickly and see what's going on. So what we have to do is, what we're going to do is we're going to pick some values in between 1 and 2, because what it's doing is it's taking any number and it's making a decision. It's domain, and it's returning a value that is only an integer. Okay, so by definition, this function, or I guess that's not the range. This is the definition of the function. The range is actually only the integers. So we have, how would I list the integers? Well, we could just say x for all x such, or sorry, that would be all y. Y such that y is in Z, and you do a scripted bolded Z, and best practice would be a curly brace. All right, so there's the official range of this function. Basically, it's only returning integer values. So let's see what's going on. Let's see how this is going to go. 1, 2, -1, -2. All right. So what I will do is I will pick -2. And I will decide, let's see, let's break up, let's go ahead and list the domain. So -2, this is negative. So this would be -1/2. I gotta go backwards. -1/2, and then -3/2. All right, so then between -2 and -3/2, so this is 4/2. Is that 3/4? Hang on. The best way to do that, if you don't know, is you just add both of those numbers and then divide by 2, and it will always give you the midpoint. So you got, hold on, you got -2 plus -3/2. Let's see, this is what I love about math, that you always have to get off on these little tangents, figure things out. All right, so to change this one into an improper fraction real quick, I'm just going to say 4/2. And then that's going to be 7/2. So that will be on the other side. So I'd have to divide that by 2. So I'm getting -7/4 here. And now I want to check it. But then on the other side of 2 would be 7/2, which we're not going to worry about. Hang on. See, I was going to try to graph this so efficiently, and now I think that'll give us enough points, though. So at least, okay. Yeah, 1.75, and then 1.5, okay. And then I knew it, I just didn't trust it. So I gotta use the calculator. Seeing is believing sometimes. All right. So then between -1 and 3/2, so this is gonna be 2/2, 3, is that 3/4? Is that 3/4? No, this is 3/4. -1 and -1/2 is -3/4. So this is -3. Hang on. What would that one be? -1. Make it a little bit smaller. Right here. So halfway between -3/2 and -1 divided by 2. Just to find this point right here, since it's not like clicking in my head what it is. This is 2/2. And so that's going to be 5/2. 5/2 divided by 2 is 5/4. Okay. So this is -5/4. 5/2. Well, I'll just finish this one out so that I'm doing the mental math, but whenever you divide by 2, you have to invert and multiply that second the denominator so that you end up with 1/2. So then 5 times 1 is 5, and 2 times 2 is 4. So 5/4. That last one I did really quick in my head, and I want to make sure that I don't, I want to be efficient, but I don't want to skip steps. Okay, so I want to double check real quick, and then I think we're good. And then all we have to do is mirror those points, so I won't have to waste time doing that. Yeah, -1.25. Okay, perfect. All right, and then actually, we've got to get so I've got 1/4, -1/4 here, and show you in a minute why I'm doing this. So that's 1, 2, and then we've got 0, positive 1/4. You get my hair out of the way. That would be, hang on, 1/4. We've got 1/2, and then 1/4, and then 3/4. I should have done the positive one first because that would have been easier for me. And then that's 3/2, and then that's 3/4. 4/4, 5/4. Okay. That looks good enough. We'll see how this goes. All right. So we're going to plug these values into our step function and evaluate it according to this rule. So what we're doing is we're taking, let's make sure I got this right. All right. So here we go. So we're going to first do f of -2. And this one's not going to be as interesting because we're looking at -2. And we're saying the nearest, so I'm looking for the greatest integer. So, and I forgot to put this up here, but n represents the greatest integer less than or equal to x. So actually -2 is the greatest integer that is less than or equal to x. So it's just -2 at this point. Okay. What's the next value on the graph though? We've got -7/4. Okay. -7/4. So when x is -7/4, what's the next value on the graph? So we're looking for the greatest integer that is less than or equal to -7/4. So, and I gotta erase this because I'm going to generate my graph, but so that is going to be -2. And I don't know what's going on with me, why I can't make a decision how I want to do my 2's, but I think I want to have them loop. Okay. All right. So then we're going to go to the next integer, -3/2. And this equals -2. So we'll say -2. And so we've got -3/2. And so I'm looking for the greatest integer that is less than or equal to 3/2. So that's also -2. And so on and so forth. So we have f of -5/4. And you can't see what I'm writing. I'm going to stretch my arm out a little bit. We're going to plug in -5/4 now. And the greatest integer that is less than or equal to 5/4 is -2. So then we're going to go ahead and plug in -1. So the greatest integer less than or equal to -1 is actually -1 now. And so all of these values are going to go to -1. So we can say, because we have a pattern here. So we got -3/4 is -1. -1/2 is -1. -1/4 is -1. And then you get to 0, f of 0. And then at 0, something special happens. Because the greatest integer less than or equal to 0 is 0. And then, so it continues. And then with 1/4, 1/2, 3/4, the greatest integer less than or equal to 0 is 0. So for all of those, I'm just going to get 0. So I can say 1/4, 1/2, and 1/3. Wait, 1/2, 3/4. They're all going to 0. Okay, so I have enough points where we can go ahead and continue the table here, maybe, and then finish X, Y. So 3/4 all the way up to 1. And then when X is 1, Y is 1. And then for all these values, 3/4, 3/2, hang on, I'll put these in here real quick. 5/4 and 2, what we're going to go through. We have all of these values going to 1 until you get to 2, and then you're up at 2 again. So when you sketch this graph, you're going to start by locating your first value. So we've got -2 way down here. And then we're going, let's see, 7/4 is -2. 3/2, 5/4. So all these values are on this graph all the way till you get to -1. And at -1, you're going to have an open circle, because -1, what this is saying is that you get all the way to the point, you get the closeness, you get all the way to that point, and then when you get to that point, then you go up. Because at -1, you're here. -1 is on the graph. So that is a point solid dot that's on the graph. And then you're going all the way to 0. That's -1. We gotta get this exact here. -1. You're going all the way to 0, and then at 0, you're going to have an open circle. Let's see if I can get this in here. Little scrubbies. I can paint an open circle on that. Because it's crucial. It's an open point at 0, because 0, 0 is now on the graph. So you have -1/4, -1. What you're doing, you could check every rational number that exists between -1/4 and 0, and every single one of them would return that integer that's less than or equal to it until you get to that value. And so we have to make sure that we have an open circle. So we're not including, we got to include this value. 0, 0 is on the graph. 0, -1 does not exist on this graph. It's kind of a big deal. And so then this would be a very crooked staircase, wouldn't it? That looks a little crooked there. Okay, maybe that looks a little bit better anyway. All right, good thing no one's going to be walking on it, huh? So we've got this value here all the way to 1, and then at 1, here we've got another open circle. And then at 1, comma 1, we have this point that is existing on our graph, going all the way to 2 with an open circle at 2. And then 2, comma 2 is on the graph. And it looks pretty good, except for this thing. It just looks a little bonkers, so I'm trying to clean up this one a little bit. 2 is just over too far. 2 is too far. Okay, just kidding. All right. A little bit smaller here. Yeah, all right. So it's not going to be perfectly symmetrical. I realize that. Don't want to get too caught up in those details that don't really matter, but basically, greatest integer function, step function. It's one of the more popular step functions. So yeah, this is how you would sketch one, and this is what's going on with them. That's the reason why the book's so weird. It's they're returning only integers. So all right, I'm gonna go ahead and call that good. I don't have any comments or any anyone posting in my chat, so I am gonna go ahead and yeah, finish early. 30 minutes is probably a good success for me. And again, if you are watching my videos, I really appreciate that. Makes me feel like I'm doing something somewhat important. And yeah, if you like my content, let me know. And I'm going to try to find something interesting to present again tomorrow. I know it's a little rough, but I am working to improve every day the best I can. So yeah, I'm not sure what I'm going to do tomorrow. If I want to do another step function, we have the ceiling function as well, but yeah, I'll be back tomorrow, same time, same place. So if you want to see me graph something, then I'll see you tomorrow. Bye.